In section 4.1.17, for the accompanying data set, part A, we want to draw a scatter diagram of the data. Part B, by hand, we're going to compute the correlation coefficient. And C, we're going to determine whether there is a linear relation between X and Y. Now, when we look at this data, X represents the explanatory variable, and Y represents the response variable. In part A, a scatter diagram is a graph that shows the relationship between two quantitative variables measured on the same individual. Each individual in the data set is represented by a point in a scatter diagram. The explanatory variable is plotted on the horizontal axis, and the response variable is plotted on the vertical axis. So what we want to do is we want to be able to create a scatter plot. Now this has already been created, but I want to show you how to do that using StatCrunch. So here are the instructions. So for scatter diagrams, 1, if necessary, you're going to enter the explanatory variable in column variable 1 and the response variable in column variable 2. And then you're going to name each column variable. Step 2, we're going to select graph and then highlight scatter plot. And step 3, we're going to choose the explanatory variable for the X column and the response variable for the Y column. And then we're going to enter the labels for the X axis and Y axis if they have them, and then enter the title for the graph and then click compute. So I'm going to go ahead and then open up the data set for this example. So here's the data set. This is what we were looking at in our example. In the upper right hand corner, we're going to be able to select that and open up StatCrunch. So we're going to open up this data in StatCrunch. And so the first column is the explanatory variable, which is already labeled as X. The second column is the response variable, which is already labeled as Y. So what we want to do is we're going to follow the instructions so that we can create our scatter plot. So we already have our data in there from StatCrunch, and so now step number 2, we're going to select graph, and then we're going to go down to scatter plot, and then we're going to look at what's in here. So it says, what is the X variable? Well, that is the explanatory variable, which is the variable of X. Then we have the Y variable, so we're going to select the Y variable. Now, where is optional. We don't need to put anything in here. We don't need to group anything by. We don't need to group options according to color. So all of these aren't necessary until we get down to the display. And we want to make sure that we can display points so that we can see all the points that are in the data. And then if we want to, we can label the X-axis and the Y-axis. And then we can call it a title. So these are optional when you're using this information to create a project. So from here, all we have to do is now is select compute. Now, if you notice, there is our scatter plot, and it closely resembles what we have here. The only thing that's different is that these increments go from 0 to 20. They're a little bit smaller than what you see here, even though this still goes from 0 to 20 up here. But you can see that these scatter points are similar to what you see over here. And now in part B, it says by hand, we're going to compute the correlation coefficient. But I would recommend, rather than doing this by hand, it would take quite a bit of time, and we don't need to do that. We can use technology to be able to find the correlation coefficient. So we already have our data listed here. So what we're going to do is we're going to follow instructions on how to do that. So the linear correlation coefficient is a measure of the strength and direction of the linear relation between two quantitative variables. Now, in order to find the linear correlation coefficient on StatCrunch, we're going to follow these instructions. Again, step 1, if necessary, we enter the explanatory variable in column 1 and the response variable in column 2, which is already done. So what we're going to do here is we're going to select stat, and then we're going to highlight summary stats, and then we're going to go down to correlation. Now once we select correlation, we need to click on the variables whose correlation that we wish to determine. They're both of the variables, so we have to select one and then use the control button to select the other one. So we have to make sure X and Y are both here. And then the next step is just hit compute. And so now that we've hit compute, we can see that the correlation between X and Y is 0.9868. And if we round it to 3 decimals, it becomes 0.987. So it's a quick and easy way of being able to get the correlation coefficient. Okay, the next step here is that we want to be able to determine, now for part C, determine whether there is a linear relation between X and Y. Okay, now the linear correlation coefficient is always between -1 and 1, inclusive. And if R is equal to +1, then a perfect positive linear relation exists between the two variables. If R is equal to -1, then a perfect negative linear relation exists between the two variables. The closer R is to +1, the stronger is the evidence of a positive association between the two variables. The closer R is to -1, the stronger is the evidence of a negative association between the two variables. If R is close to 0, then little or no evidence exists of a linear relation between the two variables. So what we want to be able to do is find the critical value for the correlation for the sample size n is equal to 5. And then we're going to use the table of critical values for the correlation coefficient. So what we're going to do is we're going to compare the correlation coefficient that we found in part B and compare it to the critical value. Okay? So, in order to find the critical value, we need to know what n is. Well, how do we know what n is? Well, we have to come back up and look at the data. Now, if you look at the data, you have one ordered pair here, which is 2, 4. We have another ordered pair, which is 4, 8. Here's another ordered pair, 6, 13. Another ordered pair, and another ordered pair. Well, how many ordered pairs do we have? Well, we have 5 ordered pairs. So, that means that the sample size is n is equal to 5. And then what we're going to do is then we're going to use the table for the critical values for the correlation coefficient. So, I'm going to go ahead and select the highlighter here. Okay, and then I'm going to look at n is equal to 5. And at n is equal to 5, you will see that the critical value is 0.878. So therefore, the critical value is 8.78. So now what do we do with that critical value? Well, to test whether the correlation between the explanatory and response variables is strong enough to conclude that there is a linear relation, we determine that the absolute value of the correlation coefficient. If the absolute value of the correlation coefficient is greater than the critical value for correlation for the given sample size, then a linear relation exists between the two variables. Otherwise, no linear relation exists. So, we have our correlation coefficient, and we found that by using StatCrunch in step B. And we know that R is equal to 0.987. If we take the absolute value of that, it's going to be positive, regardless. Okay, and then the critical value that we found was 0.878. So when we take the absolute value of this number, it becomes 0.987, which is greater than the critical value. And since the correlation coefficient is greater than the critical value, then we can say that a linear relation exists between the two variables.